All right, in the last video we learned how to use the calculator to do the inverse norm function, that is doing the normal distribution backwards so we could figure out x values. And now in this video I want to do a couple of word problems that use that skill. All right, so we did a couple of problems with the Boston Marathon example. If you remember, we did the Boston Marathon finishing times that had a mean of 226 minutes and a standard deviation of 35 minutes. Okay, but now we're going to ask a different kind of question. Race planners must set a maximum finish time for the race so that the city can reopen streets, etc. What time would leave only 1% of participants still running? Okay, so what time? We're looking for an x value. On the x-axis there's our 226 mean, and we're looking for an x value that would leave 1% of participants still running. Okay, so with these problems we have to ask ourselves, is this going to be a high x value or a low x value? Okay, so if you're thinking about people who are still running, these are going to be people who are running longer than average. They're going to have a longer time. So the x value we're looking for is going to be over here in the right tail. Okay, so the people that are in the far reaches of time for marathon finishers. And we want to set that x value so that only 1% are past that. So we have a 1% probability of leaving somebody still running when they set the maximum finish time. All right, so we want to figure out what that is. Again, I'm going to go into my calculator, second vars, to do my inverse norm, option number 3. All right. And the area, again, I want to enter in the left-tailed area associated with my x value. So once again, I've got the right tail area shaded, so I need to plug in the 0.99, the 99% that's to the left of my x value. So that's going to be our 0.99. And then we'll tell it our mean and standard deviation. So 226 minutes and a standard deviation of 35 minutes. So then inverse norm, and that gives me 307.4 minutes. Right, so they want to set that as the maximum finish time so that at most they're going to leave 1% of participants still running. Okay, so let's do another one of those. Let's clear everything out of my calculator. All right. So this one tells us that it is known that the life of a calculator manufactured by Calculators Corporation has a normal distribution with a mean of 54 months and a standard deviation of 8 months. What should the warranty period be to replace a malfunctioning calculator if the company does not want to replace more than 1% of all calculators sold? All right, so again, we're going to draw our normal distribution. This one's got a mean of 54. That's our 54 months. That is the average lifespan of this kind of calculator. And again, you got to ask yourself where this x value is going to be. Okay, so the calculator company wants to not replace more than 1%. So do they want to guarantee a high number? Do they want to guarantee a high number that's way up here on the right-hand side, or do they want to guarantee a low number down here? Okay, so they don't want to pick like 84 months and say we're going to replace your calculator at 84 months, because then they would end up replacing the majority of the calculators that they sell. They're going to want to pick a value that's down here on the left somewhere. All right, so I'm going to put my x value down there on the left. All right, and I want to make sure that only 1%, I only have a 1% chance of having a calculator die before that or at that cutoff point. So I'm going to go into my inverse norm. And again, I know I'm looking for inverse norm because I know the probability and I'm looking for the x value. When you do the normal CDF, that's when you know the x value and you're looking for the probability. All right, so I'm entering in my area. The area for inverse norm always has to be shaded to the left, and it is. So this time I don't have to subtract from 1. I've already got a left-tailed area. And then I enter in my mean and standard deviation. Mean is 54 months. My standard deviation is 8 months. And then the calculator will tell me what that x coordinate needs to be. All right, so we get 35.3 and change. I'll say round that off to 35.4 months. And for a calculator warranty, that's a little bit of a strange thing to say that they're going to guarantee it for 35.4 months. So probably since that's so close to 3 years, we'll just say 3 years is our warranty. All right. Okay, so there's our two examples of using the inverse norm for a word problem, and I will see you all in class on Wednesday.